rewrite the equation in vertex form. So I'm going to move the 8 to the opposite side. Then I'm going to factor out a 9. 9 divided by 9 is 1. Negative 6 divided by 9 is negative, and 6 divided by 9 reduces to 2/3. Okay, now take the b value and you're going to divide it by 2. Now you could do that in a calculator, just realize really what you end up doing is you double the bottom number. So when I double 3, it becomes a 6. And 2 over 6 can reduce to 1/3. But if that is confusing to you, you're welcome to use a calculator and go negative 2/3 divided by 2, then hit math, fraction, enter, enter. Okay, now we need to take this value of negative 1/3, make sure it is in parentheses, and we're going to square it. So negative 1/3 squared ends up being positive 1/9. That's what we're going to add to the right-hand side. The biggest mistake students make is they also want to do plus 1/9 on the left. Draw an arrow from the 9 to the 1/9. You have to take that leading coefficient and multiply it by 1/9. So for those that can see, it's going to be 1. That is correct. If not, you're going to take 9 times 1/9 and get an answer of 1. So this value is really 1, so I'm going to go plus 1 now on the left. 8 plus 1 is 9. Now move that 9 back to the right-hand side. In doing so, it makes it negative. What does it reveal about vertex form? This particular problem tells us you have a vertex of 1/3, negative 9. It tells you that it is going to open upward. And the 9 tells you that it is vertically stretched by a factor of 9. The larger the number, the skinnier your parabola is going to be. Okay, let's see if we can write this same function now in factored form. Remember that not all quadratic functions can be factored. So 9 times negative 8 is negative 72. Even if you know the answer, I'm going to slowly go through and check my options to figure out, is there a combination that multiplies to get an answer of negative 72 and combines to give you negative 6? No. No. I'm going to try 72 divided by 3. That's a no. 4. No. 6 and 12 do work. 6 and 12 do work. So it must be a minus 12 and a plus 6. Since the leading coefficient is different than 1, divide by 9 and reduce the fractions. And this to me is the most important step right there. Now if I do bottoms up, it looks like this. Remember, factored form is sometimes called intercept form. So what does factored form reveal about this graph? Well, it tells me that the x-intercepts occur, and the reason I like this step, at positive 4/3 and 0 and negative 2/3 and 0. And there's a hidden a out front that's a positive 1. So it also tells me that it is going to open upward. Okay, so let's start with graphing some of this. We are going to estimate where positive 1/3 and negative 9 are. So we're going to go over to positive 1/3 estimation and down 9. And now, even though it doesn't say to, I'm going to have you draw a dotted line going vertically through the vertex to represent the axis of symmetry. Remember, your axis of symmetry cuts your parabola into 2 equal parts. Now I'm going to turn these fractions representing your x-intercepts into decimals. So 4/3 is approximately 1.3. So go to 1.3. And negative 2/3 is approximately negative 0.6. And you're thinking, oh my gosh, how do I make this parabola? Well, remember, and by the way, let's go look back up here first. This negative 8 in standard form tells you the y-intercept. So graph the y-intercept of negative 8. When we place this function into vertex form, I knew it was going to be a very skinny or slender parabola because this number was so large. Okay, as a reminder, as it's going up, it's being pulled to the left, and as it's going up, it's being pulled to the right on the right-hand side. So the domain, no limit how far it goes to the left and right. Range, starting from the bottom, it goes as low as negative 9, touching that point. There's no limit how high it goes. End behavior. As we go to the left and we analyze, we can see it's going upward. And as we go to the right and we analyze, we can also see it's moving up. Now down below, I'm going to choose to do this on a different piece of paper, but it says find the solutions. Remember, solutions are x-intercepts, zeros. What's the other one? I'm missing. Roots, okay? All different words for solution. Using either quadratic formula or completing the square. You're going to do the method you prefer to use. So I'm going to do completing the square, but if you prefer to use quadratic formula, go for it. Factoring out at 9. 9 divided by 9 is 1. Negative 6 divided by 9 is negative 6/9. I'm going to reduce this to 2/3. Now, divide by 9. I know we don't do that when we put it into vertex form, but when we're using completing the square to solve, we do divide the leading coefficient. Now take this b value and divide it by 2. When you divide it by 2, you really double the bottom, so it becomes negative 2/6, which reduces to negative 1/3. So I have to go back and fill in this piece. So I want to know, what is negative 1/3 squared? Well, negative 1 times negative 1 is positive 1, and 3 times 3 is 9. Whatever I place here, I also need to place on the right-hand side to keep the equations balanced. Now normally I would suggest use a calculator, plug this into the calculator and let that do the work. But here we can see we already have a common denominator. 8 plus 1 is 9, and 9 over 9 is 1. Take the square root of both sides, recognizing you're going to have 2 answers. Square root of 1 is 1. Now move the negative 1/3 to the opposite side. When you do so, it goes in front of the plus or minus. One time we will add, the next time we are going to subtract. So 4/3 is one answer. -2/3 is the second answer. Now let's confirm we are able to achieve the same answers when we use the factoring, which we were.